Hi guys, I'm Rao Maraj and we'll be discussing quadratic inequalities. So let's get started. So inequalities are just equations that just have these signs, the less than, greater than, less than and equal to, or greater and equal to instead of the equal to sign that we are used to seeing. And a perfect example of an inequality is just ax plus b, which is less than and equal to 0. Inequality is seen every day, like women being paid less than men, and more black students getting accepted to university than white students, etc. And quadratic inequality is in the form ax squared plus bx plus c, having any one of these signs, and then you have 0 on either the left or the right hand side. So the steps to solving quadratic inequalities are as follows. You first get the form ax squared plus bx plus c, any one of these signs, and then you have 0 on either side. Then you factorize this ax squared plus bx plus c expression to get the factors, and then you obtain the critical values, and then you plot a rough sketch of the function ax squared plus bx plus c, which is just this guy here, using the x-intercepts, which are the critical values, and the guide is the x-axis. Okay, so let's draw our axes, y and then the x. I'm going to draw a parabola in purple. Okay, so here's our parabola. And there are some points we need to note. Sorry if this is badly written. The less than sign means that the graph is beneath the x-axis and it does not touch the x-axis. So let's say if you have some quadratic expression being less than 0, all that means is that the points that do not touch the x-axis but are beneath the x-axis, those are included points. Those are the included points that we want, and that represents less than 0. Okay. Next point is that the greater than sign means that the graph is above the x-axis and it does not touch the x-axis. So if you don't see the equals to sign, then it simply means that it does not touch the x-axis, that all the points that we want must not touch the x-axis. So in red, what this means is that all the points that don't touch the x-axis, that do not touch the x-axis, they are included, but above the x-axis, they are included. So they don't touch the x-axis, but they are above the x-axis. And that's what the greater than 0 inequality represents. It represents all the points that don't touch the x-axis, but are above. And the less than sign, less than 0 sign in green, they are all the points that don't touch the x-axis, but are beneath the x-axis. Okay. Now we get to the point where we have the less than equal to sign, means that they are beneath the x-axis. So the less than means that less than 0 means that it's beneath the x-axis. And if it has the equal to sign, then what it means is that it touches the x-axis. So we are including all the points that touch the x-axis. So all these points that are touching the x-axis but are beneath the x-axis. they are less than and equal to 0. Okay. And finally, the less than and equal to sign means that the graph is above the x-axis and it touches the x-axis. So all the points that touch the x-axis and above the x-axis, so it touches it and it's above the x-axis, that represents the greater than and equal to 0. Okay? And that's how you use the graphical method or the parabola method to solve quadratic inequalities. I hope that makes sense to you guys. If it doesn't, please leave a comment. We're going to solve a quadratic inequality. So let's solve this inequality, which is x squared minus 3x plus 2, which is less than and equal to 0. Okay? If you are ambitious and you are eager to learn fast, try this method and compare your solution to our solution. So here's our solution. We have the standard ax squared plus bx plus c form. All we need to do now is just factorize this left-hand side as we have over here. So we have x minus 2 times x minus 1, which is less than and equal to 0. And by inspection, our critical values are going to be x is equal to 2 and x is equal to 1. So we plot those points and draw a parabola. So here we have x is equal to 1 and x is equal to 2. It's in black because of the equals to sign. I'm including those points. That's why I'm drawing it in black. And then we draw our parabola, which is this nice red curve. Now, all we have to do is look at the sign. We have less than and equal to 0. And if we go back, we said that if it's less than, it's beneath the x-axis. And if you have the equal to sign, it means that the points that are on the x-axis are included. Okay, so I'll use my nice green color to show you. So here, I'm including this point, this black point. I'm shading it in green because I'm including it. Okay, and all the points that are beneath because of the less than 0 sign. So all the points that are beneath the x-axis, I'm drawing in green. Those are all the points that are less than and equal to 0. So the green points are just the y values. And what corresponds to these values is this red line, which are all the x values that correspond to the green values. So this nice red line corresponds to all these green values which are included. And from this, we can see here that if you have x larger and equal to 1, but less than and equal to 2, then it will satisfy this inequality. Okay, so if you have x being greater than and equal to 1, but less than and equal to 2, then this inequality will hold. So let's try values where x is bigger and equal to 1, but less than and equal to 2. Let's try x is equal to, let's say, 1.5, which is just 3 over 2. Okay, so just substitute this at 3 over 2 into the left hand side. So we have 3 over 2 all squared, which is just going to give us 9 over 4 minus 3 times 3 over 2, and 3 times 3 over 2 is just going to give us 9 over 2, and we add it to 2 and then plus 2. We bring down the plus 2. Okay, so plus 2. Okay, now our lowest common denominator is going to be what? Our LCD is just 2. I'm going to choose 4 as my common denominator. So I'll have 9 over 4. So I have 9 over 4 minus, I can write 9 over 2 as 18 over 4, and the plus 2 I can write it as plus 4 over 2, because 4 over 2 is going to give me 2. So plus 4 over, no. Instead, I'll just make this 8 over 4. You can write the 2 as 8 over 4. So my bad. Okay. Now, since the denominators are same in each term, what we can do is we can just add the numerators. So it's 9 minus 18 plus 8. So 9 plus 8 is going to be 17. So it is going to be a 17 minus 18. So it's just going to be here. And we know that 17 minus 18 is going to be a minus 1 over 4, which is negative. In other words, it's less than 0. So does it satisfy our inequality? The answer is yes, because it's less than 0. Okay. So less than and equal to 0. So the equal to 0 part comes from x being 2 and x being 1. You can try other values. You can maybe even try x is equal to, any number between 1 and 2, like maybe x is equal to 1.75. Okay, substitute 1.75 in this expression and you should get an answer that's negative. Okay, and so our final answer is just this guy here, which is the same as that guy in red. All right, I'll clear all my drawings. That's our solution. So our solution is this guy here. Let's try our next inequality, which is something that's not so standard, like minus 6y less than or equal to minus 2y squared. You're welcome to try this example, but you need to use the same procedure we used in the previous example. Okay, so pause the video and work it out. Okay, it's freezing. So here's our solution. We take the minus 6y to the right hand side and it becomes a plus 6y, as you can see over here. So we took this minus 6y to the right hand side to become a plus 6y. Next, we take minus 2y as a common factor. So you have 0 being less than or equal to minus 2y times y minus 3. Okay, and you divide both sides by minus 2. You're going to have 0 being greater than or equal to y into y minus 3. Notice that the sign changes when you divide by negative. Okay, so then since you have 0 being greater than or equal to y into y minus 3, you could also write it as y into y minus 3 being less than and equal to 0. Okay, it's the same thing. You can think of it as a crocodile's mouth. So let's say you have numbers 1 and 2. Okay, and you have the fact we know that 2 is greater than 1. Okay, you can think of it as a crocodile that has sharp teeth, and the crocodile is greedy and wants more meat. So think of it as a shark or a crocodile. Think of this greater than and less than sign as a crocodile's mouth. Think of it as this crocodile mouth that wants more meat. Okay, right. So since we have y into y minus 3 being less than or equal to 0, the critical values are y is equal to 0 and y is equal to 3. So then what we do is we plot them and then plot the parabola. So we draw our axes. So here we have y is equal to 0 being plotted and y is equal to 3 being plotted. And then we just draw our parabola, which is this not so good looking curve. We have less than equal to, so that means it's beneath the x-axis, and it's equal means it touches the x-axis. So it's just this. Means that's the points that touch the x-axis and are beneath the x-axis, they are included. So they are being included here. And the x values that correspond to these y values, which are in red, I'll draw in blue. So these are the x values that contribute, in other words, correspond to these red y values. Okay, we have the equal to sign. That means that y is equal to 0 is included in our data set, and y is equal to 3 is included. Okay, so you would have learned that in your set builder notation. So here we have y being greater than and equal to 0 because 0 is included. Okay, y being greater than and equal to 0. What we want, being less than and equal to 0. Y being greater than or equal to 0, sorry, my bad. But less than and equal to 3. So you have less than and equal to 3. Okay. And our final solution is this guy here. You can try values. Like you can try maybe y is equal to any number that's, you know, less than n, that's greater than 0 and less than 3. So let's try y is equal to 1. Okay, so then you just plug it here. So you have y being 1 times 1 minus 3. Okay, that being equal to 1. And we know that 1 minus 3 is going to give us a minus 2, which is equal to minus 2, because minus 2 times 1 is minus 2, which is less than 0. And then check to see if it satisfies the inequality. Since it's less than 0, it satisfies our inequality. You can even try, let's say, y is equal to y is equal to 2. Okay, so here you can plug in. So here you have 2 into 2 minus 3. That's going to give us 2 times 2 minus 3 is going to be a minus 1. And 2 times minus 1 is going to give us a minus 2, which is less than 0. And that satisfies our inequality here. Okay, the equals to part comes from the fact that y can be 0 or y can be 3. Okay, so that's how you check to see if your inequality, your restriction for your x or your y satisfies this guy on the left hand side or the right hand side. Okay, whichever side you choose to put it on. I hope that helps you understand inequalities better. If it doesn't, then here's another example. Solve the following inequality. So here you have the square root of 6 minus r being greater than r minus 6. So you need to get into its standard form. And to do that, we're going to square. We're going to square both sides. We're going to square both sides. To get this form. So when you square the left hand side, so the square of the square root just gives you just the number inside the square root, which is 6 minus r being greater than r minus 6 all squared. And we can expand the right hand side as follows. If we square r minus 6, we will get r squared minus 12r plus 36. And then we can take the 6 minus r to the right hand side to give us r minus 6. And that will give us 0 is greater than r squared minus 11r plus 30, which we can also write as less than 0. Okay, it's the same thing. So you can think of it as a crocodile coming to eat the zero instead of this r squared minus 11r plus 30 number. Okay, in other words, you can just forget this side, just only focus on this side. Okay, then what you do is you factorize the right hand side to r minus 5 and r minus 6. So you can get rid of all of this get rid of this block, and then you'll just have r minus 5 times r minus 6 being less than 0. Okay, so our critical values by inspection are going to be r is equal to 5 and r is equal to 6. So then we're going to just plot those points. So since we don't have an equal to sign, means we're not including those points. Okay, so we're not including r is equal to 5, and we are not including r is equal to 6. Okay, we plot our parabola, and since we have r minus 5 and r minus 6 being less than 0, what it means is that we take only the numbers that are beneath the x-axis, but we don't really include the values on the x-axis. So we're not going to include r is equal to 5, and we're not going to include r is equal to 6. Okay, so I'll use my green and making it a bit. So we don't include r is equal to 5. We only take the values that are beneath the x-axis because we have a less than 0. Okay, so we only want this portion. Okay, so since we're not including 5 and 6, so then only this portion is going to satisfy our inequality. This portion is what we're looking for, and the values that correspond to this, the x values that correspond to this, are just going to be, this red horizontal line, which corresponds to this green line, which is a graphical representation of this entire inequality, where you have r minus 5 times r minus 6, which is less than 0. This is the green. The green curve represents this whole thing. Which are underlined in green. So this whole green curve represents this inequality. The green curve represents this entire inequality, and the red line represents all the x values. So all these x values that correspond to the green curve. In other words, the green points. All right. So from this, we can see here that r is greater than 5. 5 is not included, and less than 6. 6 is not included. Okay. And so our solution is just 5 less than r and r being less than 6, which is what I wrote in red. And you can try any values between 5 and 6. Okay, so you can think of values like maybe r being equal to 5.5. You plug that in your calculator and see if that gives you this whole relationship. Okay, I'm not going to do that because that will be time consuming. Okay, I hope that helps you understand how to solve quadratic inequalities. Now we look at some exam questions. And this is from the 2016 grade 11 exam, which is 4x minus 2x squared is less than 0. So you need to get it in the form ax squared plus bx plus c less than 0, which is done here. So go ahead and work this out. So our solution is as follows. We first take 2x out as a common factor. So we have 2x into 2 minus x being less than 0. And from inspection, we can see that our critical values are going to be x is equal to 0 and x is equal to 2. So here's this next step where we divide both sides by 2. The sign does not change. And we have our critical values at x is equal to 0 and x is equal to 2. We look at the inequality sign. So we have a less than 0, which means that x is equal to 0 and x is equal to 2. They're not included. Okay, we draw a rough sketch of our parabola, which is this not so good looking curve. And the less than 0 means it's beneath the x-axis. So I'll draw that in green one last time. So it's this entire set of points. So it's this entire part of the graph that doesn't include the points on the x-axis. So it doesn't include x is equal to 0. And it doesn't include x is equal to 2. Okay, since it's less than 0, it means it's beneath the x-axis. And the x values that correspond to this, I'll write them red, is going to be this nice red horizontal line that's between x is equal to 0 and x is equal to 2. So these x values, they correspond to, all those green points on the graph, all these y values green. Okay, and what we can see here is that x is greater than 0 and less than 2. Okay, and you can try values between 0 and 2. Like you can try, let's say x is equal to 1. So if you try x is equal to 1, then you will have 4. Let me just reduce thickness here. So let's do this 4. So here you have 4 times 1 minus 2 times 1 all squared. And this is just going to give us 4 times 1 is just 4. And 2 times 1 all squared is just going to give us 2. So you have 4 minus 2, which is equal to 2. And that is something I did wrong here now. That is greater than 0. What did we do wrong now? Did we do anything wrong? Well, we factorized. We're worried here now. I'll check what went wrong here. You guys should work this out, and so what I suggest you guys do is you should identify what we should do is we should identify what went wrong. because this is, let's see what we did wrong here. So in this step, we factorized, we took 2x out as a common factor, right? So you had 2x into 2 minus x being less than 0, okay? So you have x, we divided both sides by 2, so then that led us to add to it being x into x minus 2 being less than 0. So now what happened? So here we have then we drew our points. We didn't include 0 and 2. They're not included. Then we draw a curve. We looked at the inequality sign, it was less than 0, means it's beneath the x-axis. We drew it in green. And then the red line represents the x values. Now what went wrong here? Let's look at our algebra. So 4 times 1 minus 2 into, I don't know. So you need to identify what went wrong here. Okay. Let's look at some exam questions here. The November 2018 exam. So let's solve for x here. So where we have 2x squared minus 2 being greater than or equal to 3x, we can take this 3x term to the other side to give us 2x squared minus 3x minus 2 being greater than or equal to 0. We can then factorize to get 2x plus 1 and then x minus 2. Let's see how we got those factors. So we know that 2x times x is going to give us 2x squared. What else we also know? We know that 1 times minus 2 is going to give us minus 2 here. Then all we do is we cross multiply and then we add to get minus 3. So in other words, what we're saying is that here we cross multiply. So minus 2x times minus 2 is going to give me minus 4x and cross multiply x times 1 is going to just give me x. So it's just going to be an x. We add, and we can see that minus 4 plus x is just going to give us minus 3x. All right, which is what we have in this middle term. So that's how you find the factors. So then you have this 1, which is understood to be plus 1. And that's how you find your factors. So you have 2x plus 1, and you have x minus 2. That's how you find the factors. Okay. Okay, so we have our factors, and by solving the quadratic equation, we'll have the critical values x is equal to minus half and x is equal to 2. So then we plot our critical values. So since we have the equals to sign, we're including it. So we have x is equal to minus half this side, and we have x is equal to 2. And then we just draw our parabola, which is this curve. All right, and then we look at the inequality side. So it's greater than and it's equal to 0. So what does that mean? means it's greater than means it's above the x-axis, and the equal to sign means it touches the x-axis. So all the points that touch the x-axis and are above the x-axis, they are included. So what this means is that all the points that touch the x-axis, all the points in the graph that touch the x-axis and are above the x-axis, they include. Let me just thicken this a bit. So here, all these points touching the x-axis and above the x-axis, they are included. And also here, the portion of the graph that touches the x-axis and is above the x-axis, that's included. All right. And then we just find the x values that correspond to these green curves, which are these values here. Okay. So what we can see here, that x has to be so what we can see here is that x has to be less than and equal to, because we're including the minus half, and we can see here that x has to be greater than and equal to 2. So x is greater than and equal to 2. Okay, as we see over here. And you can take any points. Let's say x is equal to 3. You tried. So that if you have x is equal to 3, you can plug it in. You can plug it in, and we know that 2 times 3 is going to give us 6, and 6 plus 1 is 7. And here we have 3 minus 2, which is 1, and 7 times 1 is 7, which is greater than 0. So x is equal to 3 satisfies that. Okay. And since you have x being less than and equal to minus half, you can think of maybe x being equal to minus 1. So 2 times minus 1 is minus 2, and minus 2 plus 1 is going to give me a minus 1. And here I have, let me just work this out, right? So let's say x was equal to minus 1. So I have 2 to minus 1 plus 1 into minus 1 minus 2. I know that 2 times minus 1 is minus 2, and minus 2 plus 1 is going to give me a minus 1. And minus 1 minus 2 is going to give me a minus 3. And if I multiply that, minus 1 times minus 3, that's going to give me a 3, which is greater than 0, which is what I'm looking for. Okay? Back to where I said you can try, let's say x is equal to 3. So if you tried x is equal to 3, you're going to have, let me not do that one. So you have 2 into 3 plus 1 times 3 minus 2 which is equal to 2 times 3 is 6 plus 1 is 7. So you have 7, and 3 minus 2 is just going to be 1, and 7 times 1 is 7, and that is greater than 0, which is what we wanted over here, which is what we want. So that's how you check to see if your inequalities match. Okay. So thank you for attending, and I couldn't have done it without my Siavula textbook. If you have a Siavula textbook, good for you. You cannot, it's accessible on the internet. So access it, read the chapters, and practice the examples. If you do that, you will pass your exam with flying colors. Thank you and goodbye. Okay, so I'm going to stop recording now.